Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're going to be starting a new section, navigation. We'll try to cover navigation in 3 videos. So this is going to be the first part of those 3 videos. First thing is that what are the common ways of navigation? So we're going to be covering 3 common ways to navigate. Number 1 is it's called pilotage. Then we have dead reckoning. And the third one is using the radio navigation. So pilotage means like by reference to the visible landmark. So the pilot is just looking outside and he is looking on the surroundings and making the decisions on that. And the second one is the dead reckoning. So you may or may not have the like the sectional chart, and you are actually computing everything, the direction and the distance from the known positions. So that would be called the dead reckoning. And the radio navigation is like where you are using the radio aids in order to navigate. Then what charts are available for the VFR? The charts we use for the VFR, right? The most famous one is the sectional chart. So this is like 6.86 nautical miles per inches. So 6.86 nautical miles per inches is like the dimension of that, and it is designed for the visual navigation of like normally slow to medium speed aircraft. Then we've got the VFR terminal area charts, also known as the TACs. So this TAC depicts the Class B airspace. It is very similar to the sectional chart, but it is kind of a zoomed in version. So you can say, so here we have per inch, we have 3.43 nautical miles coverage, only designed for the Class B airspace. Also the sectional charts and both the tags, they are like valid for 6 months, and they are not valid, they are revised every 6 months, right? And then we've got the VFR flyaway planning charts. Okay, so this chart is printed on the reverse side of the tag charts. So the same tag chart, but it's the on the reverse side of the tag charts. So the coverage is same as the associated tag. They depict flight paths and altitude recommended for use to bypass high traffic areas. So again, as I said, the tags are for the Class B Bravo airspace. So on the reverse side, you will find these flyaway planning charts. They will actually they will have the recommended flight paths basically to avoid the traffic. Okay, now if we have the EFBs, known as the electronic flight bags, like are they approved for the use as a replacement to the POH, the paper reference material, and the supplement charts in the cockpit? So the answer is yes. So if you have the electronic flight bags, they can be used during all phases of flight operations and you don't need the paper reference materials. Okay, the fourth one is like basically I'm just gonna name some of the things which you should be aware uh, uh, on the sectional charts. I'm not gonna be explaining or showing like where are those, but just calling them out so that you know when you are doing the flight review, you should know like where what are these zones, and like how you can find them on the sectional chart. So then you should be able to locate abandoned airports, air defense identification zone, airport elevation, airports with a rotating beacon, airports with lighting facilities, airports with services, alert area, approach control frequencies, ATIS, Class Bravo airspace, Class Charlie airspace, Class Delta airspace, Class Delta airspace ceiling, Class Echo airspace, controlled airspace 700-foot floor, Class Echo airspace, controlled airspace 1200-foot floor, Class E surface area, Class E transition area, Class Golf airspace, CTAF, flight service stations frequencies, glider operating area, hard surface runway airports, high VOS, IFR route, isogonic lines, and some of them we're going to be covering like what these isogonic lines are, maximum elevation figures, military airports, military operations area, military training routes, mode C wheel, national security area, no fixed wing special VFR available, non hard surfaced runways, non directional radio beacons, non tower controlled airports, obstructions above 1000 above ground level, obstructions below 1000 feet above ground level, parachute jumping areas, part time lighting, pilot controlled lighting, private airports, prohibited area, restricted area, and the list goes on and on. And there are few more: runway length, special conservation area, special flight rules area, unicom frequencies, VFR transition route, VFR waypoint, Victor Airways, visual checkpoints, VOLTAC, warning area, TRSA, terminal radar service area. Yeah, those are the ones which basically you should be really good in reading out the sectional charts. Okay, we're going to be talking about the isogonic line. So these are the magenta lines on the aeronautical charts, the sectional charts too. These lines connect points of equal magnetic variation. They show the amount and direction of magnetic variation, and which does change time by time. Sorry, time to time it does change. So what is this magnetic variation? So the variation is the angle between the true north and the magnetic north. So it is expressed as east variation or west variation, depending upon whether the magnetic north is to the east or to the west of the true north, right? Okay, then we have this. So how if you have the true north, right? If you have the true direction, how would you be able to figure out what is the magnetic direction? So to convert true course or heading to magnetic course or heading, uh, note that the variation shown by the nearest isogonic line. So if the variation is west, you need to add, and if it is east, you need to subtract. So you can remember it by this saying that east is least, meaning you need to subtract, and west is best, meaning you need to add. So that's how we figure out if we have the true directions, what would be the magnetic directions. Okay, briefly I wanted to talk about the longitude and latitude. It's was what we uh, read in science. That's nothing different. So basically these are the circles parallel to the equator, and parallels of latitude enable us to measure distance in degrees, latitude north or south of the equator. So basically these are the parallel lines of the equator, uh, right? So the parallel lines of the equator are gonna be the latitude, and the perpendicular of that, right, from north to south, kind of cutting the. So if this is equator, these lines are gonna be the uh, latitude, and the ones over here are gonna be the longitude on the globe. Okay, now we did talk about magnetic variation. What is the magnetic deviation? So the magnetic deviation is caused because of the magnetic influences within the airport itself. It could be the electrical circuits, radios, lights, tools, engine, magnetized things. So the compass needle is frequently deflected from its normal reading. That is called the magnetic deviation. And the last thing is that uh, the navigational aids. What are the common navigational aids? Uh, I'm just gonna write them down here. One is the VOR, then we have the VORTEC, then DME, then RNAV. So VORTEC stands for the very high frequency omnidirectional range, and VOR stands for very high frequency omnidirectional range, and then VORTEC is the VHF, which means very high frequency omnidirectional range tactical air navigation, uh, like Cessnas have it, VORTEC and those ones. DME is the distance measuring equipment, and the RNAV is like it's basically that includes the VOR, DME referenced, and the GPS. All of them, like the advanced equipment, uh, and the GPS, that comes under this area navigation. Those were the things I wanted to cover in this video. Thanks for watching.